Hi guys, I recently purchased the Quick 205 soldering station. It's supposed to be 150 watts. It was used. When I first turned it on, I set it for 250 degrees. I tried to melt the solder, nothing happened. So I tried to set the temperature for 350. Now it started to melt. So I thought there is something problem with the measuring of the temperature of the soldering tip. So I started to take it apart, and I would like to share with you what I discovered with this unit. I went before online to checking the manual because they told me, I've been told this unit has to be calibrated the temperature for every tip you use. So maybe I was thinking maybe that there is something wrong with the calibration. So I went online. They told me a certain of I was talking to Quick actually, and they sent me a piece of copy of the manual, just that part of it which is dealing with the calibration. But actually the keyboard combination they sent me didn't work at all, so I tried to figure out how to do it. Basically you have to push these two buttons, the arrow buttons, while you are switching the power on, and it's entering into the calibration mode, and you can enter the temperature of the tip by measuring it with this device. I tried it, it didn't work. It became a little bit better. Now the temperature difference between the real one and at the end of the tip and the measured one had about 60-70 degrees difference. Mainly it was showing 300 degrees, and I was measured 240 degrees at the end of the tip. So it didn't really work out, so I decided to take it apart. And I'm going to show you what is inside in this soldering station. Hopefully you will see it. We look a little bit inside and you can see the transformator. This transformator pretty big. It can be 100-150 watts, so that's fine. There is inside a wall, you can see it. This one is noise filter for the main. So it won't bother all of your instruments, and there is power MOSFET over there. It's not an IGBT because it's using high frequencies, so they use the MOSFETs, and this MOSFET taking 17 amps. Now probably this unit is working with 24 volts as most of them. I didn't measure it, but I guess most of the soldering irons are working by 24 volts. It makes it about 150 watts, should be over a little bit over 6 amps. So I don't know if you're looking these wires here, how is that 6 amps? I don't know. And how is this connections are rated for 6 amps? I don't know either. So I don't really believe for this 150 watts. Okay, let's a little bit closer inside what is in this unit. I try to turn it some way you can see it. There is two printed circuit boards controlling the power. The top one, that's mainly the power supply of the unit, and the filters and stuff like that. And the control board is on the bottom. It's like a sandwich. On the bottom board there is a Atmel Mega 8 processor, which is a very small one, but it has enough pins to drive the LEDs, the buttons, and it has an AD converter as well for measuring the temperature of the iron. By the way, this is the temperature sensor of the iron. So, but why I was open the iron up, just showing you the diameter of the wires are very small. Guys, how do you drive 7 amps on these small wires? Tell me. Something miracle going on this soldering iron. I don't know how it can be 150 watts, but whatever. So the connectors of the boards, these are the top ones. These are responsible for the power. Here the AC is going in and the IC going out to the main board or the controller board. That one here might be a little bit difficult to see. I try to get it a little bit closer here. This 7-pin connector is the ISP for the in-circuit programming. So this one was the regulated output, the PWM, and the power. It's got a separate AC for the 5 volts for the processor unit or the microcontroller. This one is going for the power transistor. This one is the on-off switch of the main. This one is the connector for the fan for cooling. I don't think that's going to be used so often. This is the connector of the soldering iron. That connector goes for the temperature sensor, and this one is going for the heater of the soldering iron. Now you can see there is 3 pins for the temperature sensor. Why is 3 pins? I was thinking because the temperature sensor has only 2 pins. There is an extra pin they use as an input, but at this particular soldering iron it's not connected. It's the white one. It's not connected actually. It's an input for the microcontrollers. Haven't been used for anything. So really the temperature sensor is the red and blue wire here. Why 3 pins goes for the heater as well? Because one of them, the blue one, is connected to the ground of the machine and connected for the shield of the soldering iron, taking care of for your life. And the other 2 wires goes for the heater, the red and yellow one. Not really 6 amps wires, I guess. But if you look at the soldering iron, guys, how you can send 6 amps on these wires are really tiny, miny more. I don't know how they do it or whatever. You can see here the heater wire is very small as well, so I don't think it's 150 watts, but whatever. I believe you anyway. So what I was doing, I was disassembling the whole things. I don't do it at the moment because I put everything together and it works like that. I don't want to touch it anymore. So I was making a schematic because I couldn't find anywhere else, so I was just drawing it quickly. If there is any mistake I've done, look over it. I didn't want to be too detailful with it. I just wanted to do a quick quick drawing, just make sure I see where is the amp of the temperature sensor, just make sure I can temper it and I can adjust it. So this is what I did finally. The streamer potentiometer, I can adjust the amplification of the op amp. You can see that on the drawing, if it's with you, I'm going to link that onto the bottom. so you can download it if you want, and you can see it what's going on. It's marked with a pink circle where is the resistor which is responsible for the amplification of the op-amp. It's marked on the printed circuit board R34, and it's a 20k resistor. Happily, they thought you might need or they might need adjust this amplification, so they prepared the potmeter on the PCB, but it's actually shorted. So the first thing you have to do, you cut this short and you short out the R34 R34 resistor, and you connect this one for the place of the potentiometer. You will see anyway on the schematic what I mean. It's basically this potentiometer is a 10k potentiometer, and there is a 15k resistor in serial, and this connected to the board. That is the potentiometer you will find on the PCB easily, and after then you will be able to set the temperature of this soldering iron properly, and you can use it finally. But I think at the end of it, it's fixed, it's working now properly. I was using this temperature meter of the soldering iron, just make the temperature correct. So after all this modification,